In this lesson, we're going to talk about surface area of prisms and cylinders. So when you hear surface area, it's exactly what it sounds like. You're finding the area of the surfaces on your solid, okay? So for a prism, what is a prism? It's a solid with two bases that are congruent and parallel. The shape of the base determines the prism's name. So if we go back up here, the reason why it's called a rectangular prism is because the bases are rectangular. And let's say like here, this is a triangle, so this will be called a triangular prism. Now, here the length represents L, W is for the width, and H is for the height. So to find the surface area, you're finding the area of all the surfaces. So a prism has 6 sides. So that's what you're trying to find the area of all those 6 sides. Notice there's only 3 here. The reason why is because they're doing 2 times of each. So here it says 2 times length times width. So the bottom, whatever's on the bottom, you have it on top. So there's 2 of those. Then you have the length and height. So right here in front, and there's something on the back. So that's why it's twice of everything. So for more of a visual, like here, if I have to find the area of the top, there's one on the bottom. So it's 2 times that. Right here in front, there's one in back. And then I have one side and one side. So that's why you're multiplying them by 2. Okay, so let's go ahead and do this example now. We're going to find the surface area of this rectangular prism. So let's go ahead and write the surface area. The formula is 2 times length times width plus 2 times length times height plus 2 times width times height. Okay, so length times width. So that's basically here, the bottom. And remember, whatever's in the bottom's on top. So we have 2 times the length, which is 13, times the width is 7. If you prefer in the beginning, you could go ahead and just label it right away, if that makes it easier. So my length here is 13, width is 7, and height is 9. So that's always helpful if you want that to be done. Okay, next we have 2 times length times the height. So this is, right now, the top and bottom is getting done. Right? So now we're going to do the length and the height. So this is the front and the back. Kind of looks a little messy, but you're doing the front now and the back. So 2 times my length and the height. And next you have the sides right here. Your width times your height. So this on the side, there's 2 of them, is on the other side. Alrighty, and now we're just going to go ahead and multiply and then combine. So 2 times 13 times 7 gives you 182. 2 times 13 times 9, 234. And lastly, you're going to have 126. And now we're just going to add them. So my surface area for this prism is 542. Always have units. So my units are in feet. So that means I'm going to have it as feet. And we're doing area. So every time you do area, it's always squared. So it's squared. Feet squared. And that is your answer. Okay, so just following the formula. Now what if you don't have a cube, which means like the bases and everything's are squares, or a rectangle prism? What if you don't have that? For any other prisms, like for this one, this is going to be called a triangular prism, because my bases are triangle. So first we have to find the lateral area, which is area of the non-bases. And then you're going to add the area of the bases. So in other words, this is the surface area. You need H times P. So H is the height between the bases. So the top, these are my bases, right? The height between them, that's H, times P. It's the perimeter of the base. The perimeter of the base. Then you're going to go ahead, and add 2 times B. B is not just base, it's the area of the base. Okay, so let's go ahead, what we know now, let's apply this to an example. So let's go ahead and first write down the surface area. The formula is HP plus 2B. So let's find our height. My base is right here. It's a triangular base. I have 2 of them. 2 bases have to be the same. So the height between them is right here. That's what h equals. Now we need to find the perimeter of the base. So the perimeter of the base. So the base is right here. Now, in the definition it says the bases are congruent. So that means I have 15 here. So this length matches the top base, which is 9. And this right here is 12 meters. So let's find the perimeter of this base. Perimeter, again, is just the distance around it. So you're adding 9 plus 12 plus 15. So the perimeter here is going to be 36 meters. So now we have H and P so far. So we have your H, which was 16, times my perimeter, which is 36. And now we have to multiply 2 times the B, which is area of the base. So we want to find area of the base. Well, let's identify. How do we find the area of this base? Well, the shape is a triangle. So that means I need the area of a triangle. So the area of a triangle is half times your base times height. So my base of this triangle is 9, and the height of it is 12. So that means the area of my base is going to equal to 54 meters squared. Now, all we're going to do is put the 54 because there's 2 of them. And now we're going to go ahead and multiply and combine. So this will be 576 plus 108. So my surface area is going to equal to 684 meters squared. It's like we're dealing with surface area. Now let's talk about another form of a prism. We have a cylinder. A cylinder is a prism with circular bases. So the definition of a prism has 2 bases that are congruent and parallel, same thing with a cylinder. And think about it. This is a rectangle. When I roll it up, I get a cylinder. And my bases are circular. So that's what it is, a specific prism. So same thing here. We need, in order to do that, we need to find the lateral area, which is going to be 2 pi RH, and the surface area means you're going to add that to the area of the base. So my circle is my base. Area of a circle is pi r squared, and then you just multiply by 2. So that's where it came from. And then here is the sides, the lateral area, meaning not including the area of your base. Okay, so here we have R's radius, H's height. So let's go ahead and use the formula. So surface area is 2 pi r squared plus 2 pi RH. So I need just a radius and a height. Your radius is always from the center of the circle to a point on the circle, not the whole thing. So this is not the radius. It has to be halfway. This is diameter. So if my diameter here is 15, to find my radius, all I have to do is divide that by 2. So I'm going to get 7.5. And then my height, remember the height is connecting the bases, is 9. And now we just go ahead and we plug it in. Just keep an eye on, it's not always going to have radius, so make sure you could distinguish the difference. So we're going to have 2 times pi times my radius plus 2 pi times my radius again times the height. Alrighty, so order of operations, I'm going to go ahead and do my exponents and then multiply. We have 2 pi, so 7.5 squared is going to give me 56.25 plus, and then I'm going to multiply these out. I'm going to leave pi still. I'm not going to multiply the pi, and you'll see why. So you're going to multiply those out. You should get 135 pi. And now, again, I'm not multiplying the pi out, not just yet. So multiply that by 2. So we get, I'm just multiplying the numbers out. So I'm going to have 112.5 pi plus 135 pi. Now, because they both have a pi, I'm just going to add the numbers and have the pi with it. So you're going to get 247.5 pi. So now I could just multiply it and I'll get more accurate. If you don't want to do this way, you don't have to, but this is more accurate. So because they both have the pi's, I'm combining them. So I have 247.5 pi's, and then you multiply it out. So my surface area, it didn't tell us where to round it, so I'm just going to round it to the nearest hundred. 777.54. There was another 4 afterwards, that's why I didn't round up. And my unit's going to be meters squared. Alright, so now we're going to go ahead and have mixed problems for practice. Okay, the average bedroom in an apartment is approximately 6 feet by 10 feet with an 8-foot ceiling. As an interior decorator that loves the 1970s decor, you need to cover the walls with groovy flowered wallpaper. So before we go on to part A, part B, I read it once. Now I'm going to highlight any important information. And usually you're looking for numerical values. So we have a bedroom apartment. It's 6 feet by 10 feet. And watch out, just because it's not a numerical value, so that is a value, 8-foot ceiling. That's important. And what are we trying to do? We need to cover the walls. So for part A, if one roll of wallpaper covers 50 feet squared, then determine how many rolls of groovy flowered wallpaper is needed to cover the apartment bedroom. So that's important. One roll of wallpaper covers 50 feet. We need to figure out how much do we need. So before we need to know how much we need, let's figure out what we're going to do. So since we're covering the wall, I'm looking for surface area. I'm finding the area of the surface of this room. Okay, so it's a prism. Now, let's write the formula for it so we can visually see it. So the formula is the surface area of a prism. It's 2 times length times width. Now, whenever you get problems that are not like with the image there or whatever, actually think about it, because sometimes you might not need the whole formula. Alrighty, so let's pretend this is the room. Back to this clear thing. The person's in here, this is the room they're in, this is the ceiling. If I'm covering the wall with wallpaper, do I have to, what do I need to find the surface area? I need right here the length, the height. I need the height here, and let's say the length for this wall. And then for another wall, you'll need, okay, I need the width and the height. You don't need length times the width for the top or bottom. So because you're not using, you're not putting the wallpaper on the floor or the top, you don't need your length times width. You need the length times your height. You need your width times your height for the walls. So all you need for this problem is this ending. You need your height with your width and your length with your height. You don't need length times width because that means you're just multiplying the ceiling or the floor. You don't need that. So let's go ahead and do this. So surface area equals 2 times my length. Length, width, and this is my height. Length, so 2 times 16 times my height, plus 2 times my width times my height. So my surface area is going to equal to 256 plus 160. Add them. So my surface area here is 416 feet squared. That's the surface area that I need to cover the walls of wallpaper. But now, don't feel like you're done. Always check back to read the question. Do we answer the question? How many rolls of groovy flower wallpaper is needed? So how many rolls? How many rolls do we need? 1 roll costs 50 feet squared. So I'm just gonna write that down so you can see it. So one roll equals 50 feet squared. So how many rolls would you need if your surface area is 416? So you can set it as a proportion here for you to see it, or you can just divide. Notice you're just going to be dividing. Let me just show you why. So 1 roll is 50 feet squared. That's what it covers. So if I need to cover 416 feet squared, I need to know how many rolls. So rolls, surface area. So you cross multiply. It's just a visual, just to show you. So you have 416 times 1 is just 416 equals 50 times x. So you want to know how many rolls there are, you divide by 50. But again, you don't have to do this if you realize right away how much that's going to give you. So you get 8.32 when you divide 416 divided by 50. Now here's the thing. The answer, you're not going to be like, okay, well, I don't have to round up. It's just going to be 8. Now really think about this. It's a real life situation. If I need 8.32 rolls, that means 8 rolls is not enough. I still need a little bit more extra. So for this case, you need 9 rolls. Because it's actually a real world problem. You need a bit more. If you just have 8 rolls, you still need a little extra. So the answer here is you need 9 rolls. How many rolls? You need 9 rolls. So that's why we're rounding up for this particular problem. If 1 roll of paper costs $50.90, then determine the cost to re-wallpaper the apartment room. Now this is obviously before taxes because that's not included. So we have 9 rows, each one costs $50.90, so we're just going to multiply it. And this is going to be money, so make sure you have the cents in it. So it's 143.1, and make sure you have the 0 in it because it's cents. And that's your answer. Next question. The surface area of a soup can below is 51.84 inches squared. If the diameter of the can is 3 inches, find the height of the can. So let's go ahead and highlight stuff that's important that we'll be needing. So I see surface area of the soup can. They gave me the surface area. So surface area is that. Diameter, that's important, 3 inches. We want to find the height. Find height. So now that we know we're dealing with a can, that's a cylinder. So we're going to write the surface area formula first. It's 2 pi r squared plus 2 pi r h. Now, we have the surface area. So I'm going to plug it in here for SA. So we're not looking for the surface area because they already gave it to us. I need to find H. So H is the only thing I can plug in. So R, I need my radius. I don't have radius, I have a diameter. So if my diameter is 3, to find the radius, I need half of that, which is going to be 1.5. And now we're going to go ahead and plug it in. So I have 2 pi, my radius is 1.5 squared, plus 2 pi times 1.5. And h is what I'm looking for. So it might look messy, right? But now go ahead and just do your order of operations so we can organize this. So we're going to deal with exponents first. So 2 pi, 1.5 squared gives you 2.25 plus 2 times 1.5, that gives you 3. And I'm going to leave pi for now. 3 pi times your h. So leave pi's in there as much as you can. And now same thing here. I'm going to go ahead and multiply. So I get 4.5 pi plus 3 pi h. Now in the previous problems, I combined how many pi's there were and stuff. But here, because there's an h, they're not like terms, you can't do that. So just remember, this is just a number. So now we could go ahead and multiply it out. 4.5 times pi. And when we do that, we'll get 14 point, no, I'll do it after the calculator, it's more accurate. So I'm going to subtract this. I'm solving for h, so think of this as a number. Like pi is a number. Think of it, let's pretend it was like 30h, whatever. So you just move the number first, so 4.5 pi. And when I put this on the calculator, that's when I'm actually going to use your parentheses. So 51.84 minus 4.5 pi. So once you do that, you're going to get 37.7. That's just rounding it, equals 3 pi times h. My whole point is I want to solve for h. So 3 pi is being multiplied by h, so I'm going to go ahead and divide by 3 pi. Because remember, that's just the number pi. So now we have 37.7 divided by 3 pi. And you will get 4.009, blah, blah. So my height here of the can is going to be 4. And what's the units? It's in inches, so it'll be 4 inches. Now, if you don't want to deal with pi like how I was doing it, like at the end, I subtract it, you could go ahead and multiply right away, then subtract it, you know. But I try to keep it as accurate as I can, so keep it till the end. Okay, so 2 questions left. A can of sweet peas at the local grocery store has a radius of 1 inch and a height of 2 inches. How much paper is used for the label on the can of peas? So what's important here? A radius, 1 inch, and a height, 2 inches. How much paper is used for the label? So a can of peas, that looks like a cylinder. That is a cylinder. So we're going to use that surface area again. I want to find the area, I want to know how much paper is used for the label. So let's look at a can. It's not peas, but it's a can. Look at the label where it is. It's all around here. Notice it's not on the top or the bottom. This is called your base. So that means I'm not using the whole formula. I need only the part that doesn't include the base. Now if we go back to what we went over before, this was your area of the base. The lateral area, which is the area not of your base, was here. So since we're dealing with a label, I don't need the area of the base. That's the circle. I don't need that. I just want the label around it. So all you're looking for is this right here. 2 pi RH. That's the only one you need because you don't want the label to be on the top and bottom, aka the base. So now we're just going to have 2 pi times my radius, 1, and the height is 2. So multiply this all out. Now I'm just going to round to the nearest hundred. You'll get 12.57 inches squared. That's the label that you need. That's how much paper you need for the label, actually. So that's why when you read these type of problems for surface area, it doesn't mean you're using the whole formula. So you just have to actually think about real world stuff, how it's going on. And lastly, your humanities class is having a recycling project where you have to collect tin cans. If you earn 2 cents for recycling the sweet peas can from question 6, then how much can you expect to earn for recycling a tomato can that has a 2-inch radius and a height of 5.5 inches? The recycle value is proportional to the surface area. So let's highlight some important. This is how much you earn for the sweet peas from the question right above us. Okay, and then it says how much you expect to earn. So your tomato can has a, the tomato can has a 2-inch radius and a height of that. And this is the question, how much you expect to earn. So that means for this amount for the label, that's how much you earn for recycling it. You're using the same type of problem. So let's do the surface area for the tomato can. Now, yes, it's a different type of can, but again, you're just dealing with the label. That's the only thing that's recycling. That's the only thing you have. So we're not using the first portion. We're using the last one. This is the area of the base. I don't want the area of the bases. I just want the lateral area. 2 pi times my radius, 2, and a height, 5.5. I'm going to, again, put it round to the nearest hundred, so I'm going to get 69.12 inches squared. You're not done. The question is asking how much can you expect to earn? And it's proportional, it says, the recycle value is proportional to the surface area, meaning you could go ahead and make your fractions equal to each other. Now there's more than one way you can make your proportion. You could do, okay, so it's $0.02 for that surface area, because remember it says that's how much you earn for the sweet peas. You could do it that way, or the way I just see it better as, so 0. That's how much you earned for this amount. So how much will you earn with this amount, 69.12? And if you did it this way, that means if you're doing money over surface area, you would have to have money over surface area. So it just depends. You will get the exact same answer because you're multiplying, you're still cross multiplying these two, and you're going to divide after. Okay, so I just see it as this way. This is how much money I get for this amount of surface area, so how much money will I get for this amount? Doesn't matter which one you use. So you cross multiply. So notice again, up here, the same thing. 0.02 times, it comes out to the same thing because they're proportional, so it's fine. So now we're going to multiply this. You'll get 1.3824. I'm not rounding yet. And I want to solve for x. So I divide. X equals, so you get 0.1099 and blah, blah, blah. So how much are you really earning? So we're dealing with money, right? So this is in cents. So go to the nearest hundreds, right? We stop right here. Because that 9 is greater than 5, you round up. So this is X is going to be 0.11. So that means you'll earn 11 cents. So expect 11 cents from the tomato can. So just keep an eye out for what shape you have to use which formula. And when you're using the formula, just think about the problem again. Are you using the whole formula or just part